Hello, geometry. Welcome to August 1st. Hopefully everything getting closer and closer to the proof, which you'll see in next section. But this is really going to help you get there. So here we go. Reason using properties from algebra. Okay, so we're going to use like the algebra stuff, and you'll see how this will relate when we get to the geometry proofs. I can use algebraic properties for logical arguments. I can use distributive properties solving equations, and I can use equations in real world problems. So here we go. State which postulate justifies each statement. So if D is in the interior of angle ABC, let's see what we have here. A, B, C, D is in the interior. Then the measure of ABD, this measure, plus this measure is going to equal the whole thing. Well, that's angle addition postulate. Can't write today. All right. Now, if M is between X and Y, then XM plus MY is equal to XY. This is segment addition postulate. Find the measure of Mn if n is between M and P. Okay, let's see here. Okay, n is between M and P. So we'll put M here. P is in puppy. N here. Okay, MP, that's the whole length, is 6x minus 2. And MN is 4x. And MP equals 16. Okay, and we're looking for MN. All right, here we go. 6x minus 2 is equal to 16. Add 2 to both sides. 6x is equal to 18. X equals 3. Well, Mn is 4x, which is equal to 4 times 3, which is equal to 12. So far, so good. All right, here we go. Algebraic properties. I'm going to break out the highlighter. Maybe or maybe not. You'll need that. But, okay, addition property. Well, let's say we have A and B. If we add C to one side of the equation, you add C to the other. Subtraction means we're going to subtract C on both sides of the equal sign. Multiplication property, we're going to multiply both sides by the same value. And division, we're going to divide both sides by that same value. Substitution, if A equals B, you can substitute A in for B in any equation or expression. All right, here we go. Now, I know that this might seem kind of redundant, but they want us to solve this equation and then give a reason for each step. Well, the first thing I want to do, I'm going to write out the equation. 4x plus 10 is equal to 30 minus 2x. I'm going to write given. That's our given equation. I'm going to put a little star there because you're going to notice why this is important next. Well, in order to solve this, I'm going to add 2x to both sides. Well, we know to do that, but why are we doing that? Okay, we're doing addition property of equality. And here we're going to combine like terms. Now I'm going to subtract 10 on both sides. Why are we doing that? Subtraction property of equality. Like I said, go ahead and abbreviate as long as you know what these mean. Well, here I'm going to be combining like terms. 20 on that side, 6x on the left side. And then divide both sides by 6. Why am I doing that? Division property. And, of course, x is equal to 10 over 3. I just simplified. We reduce fractions. Basically, we divide the top and bottom. Oh, I put frac. All right. So in geometry, when we do a proof, we're going to start with our given a statement, go all the way until we get to what they're looking for, and we have to list the reason why each time. Okay, so algebra, we've gotten the habit of just solving the equations and not listing the reasons why. Time, I think, is a factor. So key concept, distributive property. If you have a value, whether it's a number or a variable right outside a set of parentheses, you'll distribute through. You'll have to multiply this into both of those. So A times the quantity, B plus C, is AB plus AC, where A, B, and C are all real numbers. You don't want non-real numbers such as I, but you'll be surprised that works the same way when you get to Algebra 2. So here we go. Here we go. Now, we're going to solve example 2, and we're going to give the reason for each step. And the first thing I want to do, I'm going to write down. This is my given. I'm going to use distributive property. I'm going to subtract 40 on both sides. So subtraction property of equality. I combine like terms there. Basically, when you subtract that. Divide both sides by negative 15. And I did division property of equality. And we should get negative 4. Oh, okay, not too bad. Went a little bit faster. Sorry, it's Cricket. Ooh, story problem. Shouldn't be that bad. The cost C of using a certain cell phone plan can be modeled by the plan rate formula. C equals 0.3 M. That's a minus. It's kind of hard to see that. Minus 300 plus 39.99, where M represents the number of minutes over 300. Solve for M. All right, so C equals 0.3 times M minus 300 plus 39.99. It's given. So the first thing I'm going to do is, okay, we want to solve for M, but I'm going to distribute here. So I have C is equal to 0.3 M minus, okay, I know 3 times 3 is 9, but I have a place behind that. So it's going to come over to 90, one decimal place over. Okay, combine like terms or simplify. So I'll have C is equal to 0.3 M. When I combine negative 90 and 39.90, I have negative 50 and 1 cent. Okay, now remember, I need to get M by itself, so I'm going to bring that over to the other side. Basically, that's addition property. I'm going to add the 50, 0.01 on both sides. So you get C plus 50.01 is equal to 0.3 M. Remember, our goal is to solve for M right here. So M is being multiplied by 0.3. Divide both sides by 0.3. That's your division property. Okay, now I know this seems weird, but you need to start getting in the habit of allowing a non-single numeric value for an answer. You could have an expression here, C plus 50.01 over 0.3. That's okay. Here we go. More key concepts. Reflexive. Basically, I call this the mirror. X is equal to X. AB is equal to AB. Angle A is equal to angle A. That'll come in handy. You'll see why. Symmetric property. X is equal to Y, so Y is equal to X. If A equals B, then B equals A. If AB equals CD, then CD equals AB, etc. So you can switch things around. Transitive property. A lot of people like to call this substitution. So very similar. If X equals Y and Y equals X, then if X equals Y and Y equals Z, then X equals Z. Kind of like we're getting rid of the middleman. if you've ever heard that term before. Okay, so let's play around with that. Hopefully this video is not getting too long. Go to my cheat sheet page so I don't mess this up. So let's kind of use that idea for example 4. So he's planning to add 2 stations between the beginning and the end of a commuter line. Use the information given. Determine whether AB equals BC. Okay, so one little piece that I didn't have on here is segment AC is congruent or the same length as BD. So AC is equal to BD. Okay, so that's given information. So sorry I didn't put that on there. You need to add that. Okay. Remember the reason why there's a little line here, we're not cutting it in half, we're just saying that that segment is congruent to that one. Okay, well, AC is equal to BD, and we do know that BC is equal to BC, right? This segment is equal to itself. That's reflexive. Let me show you why that's going to come in handy. This is it. AC, and I'm going to take away the BC part, is going to be the same as BD minus the BC part. Basically, I'm subtracting BC from both sides. So if I take AC and take the BC part away, I have AB left. And if I take BD and take the BC part away, I have CD left. Okay, this was our subtraction. And segment addition postulate. Remember, we're trying to figure out, is AB equal to CD? Yes, we just did it. There's our proof. Here are our reasons why. Hopefully it wasn't too confusing. Example 5. In the diagram, the measure of angle AEC, okay, that's these 2 angles, the top 2, is equal to the measure of BED, the bottom 2. Show that angle 1 and angle 3 are the same. Well, I'm going to start with measure of angle AEC is equal to the measure of angle BED. Okay, that's given. Okay, now, what do both angles, the top 2 and the bottom 2, have in common? They both have the measure of angle 2 in common. So what I'm going to do is to take that away, just like what I did with this example up here. So measure of angle AEC, take away the measure of angle 2. I'm going to subtract that on both sides of the equal sign. Measure of angle BED, take away the measure of angle 2. Basically, we're doing subtraction. Property of equality. So I have this one. I took away angle 2. What do I have left? Measure of angle 1, which is AEB. And when you have measure of BED, that's the bottom 2, and I took away angle 2, you have that bottom angle left, which is CED. Well, isn't the measure of angle AEB measure of angle 1? And isn't this the same as measure of angle 3? Alright, so what do we do here? When I subtracted on both sides, that was basically angle addition postulate. Oop. And here I just did substitution, because I know that that angle is the same as measure angle 1. And we found what they're looking for. Alright, just a little review. I found this picture online. It's actually in your book. Take a look at that, and have a nice evening.